Today we're going to look at the formal definition of a limit. Since this structure is new to us, I'll just review how this is going to work. So we're going to have three sections: the I do section, which is the section that I will do; the we do section, which is going to be a collaborative problem. That means that you're going to try it first and then watch the video solution afterward to check your answer. And lastly, we have the you do section, which will not have a solution for you and that you'll have to complete and turn in. So our formal definition of a limit says we're looking at a function f on an open interval containing some point c, and we have this variable L that's a real number. Right. Well, if it's true that as x approaches c, f of x is equal to L, then we have the epsilon and delta both greater than 0, such that this relationship holds. So you may remember from class, we talked about c and c plus delta and c minus delta. Then we could have some function here. And we talked about what this meant. Well, what we're trying to do with this formal definition is we're saying, well, as we close this gap and we get closer and closer into the value of c, what's my value L, my y value? That's all a limit is asking us, is what's our y value? What we're doing when we use the formal definition is we're finding the relationship between the distance here away from c, which is in this case delta, and the distance here, which is epsilon. So we're demonstrating the relationship between those two. So without further ado, let's look at this problem. So the first thing I'm going to do is write our limit notation below that. And then I'm also going to go ahead and give us our two parts of the definition. So we're going to let f of x minus L is an epsilon, and then we're going to find the delta that corresponds to that. Alright, so we're going to get some variable expression with epsilon, that funky looking e there, some operation happening to it, and then we're going to choose delta of that value. So let's go ahead and do this problem, and then we'll look at it in the context of a graph. So here my c, if I look up at the top, as x approaches 1, my f of x is 5/2 x plus 1, and my L is 7/2. So when I set up the first part, I've got 5/2 x plus 1 minus 7/2 less than epsilon. Combine your like terms. And then our greatest common factor here is 5/2. So we take that out. And we want to have it match with our x minus c, which in this case would be x minus 1 less than delta. So our goal is to get this x minus 1. So to do that, we have to get rid of the 5/2. And then we'll have something that we recognize. So we choose delta equal to 2/5 epsilon, because that's the relationship between the two. So if my epsilon is 1, then my delta will be 1 times 2/5 or 2/5. That's the relationship between those distances. Let's go ahead and plot our line and just show a demonstration of what we're looking at. So we start at 1, we've got 5/2, so that means we go up 5, right 2, so that would put us at 7/2, and we've got a line here. So our C in this case is 1. I feel as though I've made a mistake somewhere. I apologize for that. It is up 5/2, however, that would be off my graph, so up 5/2 over 1 would put me here. So my graph looks like that. Alright, so our C here is 1. Our L is 7/2. So I'll just write that next to them. We've got L equals 7/2 and C is equal to 1. Right, and then what we're finding here is some expression for a distance away. So it would be like saying, well, we've got this distance here, and that corresponds to some vertical distance. So this right here would be C plus delta, or in our case, we just chose delta equal to 2/5 epsilon. Can't really see that, can you? Which we said was C plus 2/5 epsilon, right? And then this relationship up here would be L plus epsilon. And then the same would be true for the other side. It would just be the difference. So we'd have C minus delta for this bound and L minus epsilon for this one. All right, so that's kind of a graphical representation as well as the formal definition. So go ahead and take this down and then try the practice problem.